Ah, I don't know what happened. It is not looking good. All right. So, my previous live stream that I was just trying to launch didn't quite work out. I apologize. I think a couple of other people were waiting on that live stream. I may have deleted it. I don't really know how to use um, computers. But now I've started a new live stream, so hopefully this is now going to work. Let's give it a go. Um, what can I say right now? Hang on, let me. My previous live stream that I was just trying to mute that one. Okay, so this has got some people watching. Hello, everybody. Welcome to the second. Now this should be the second. I'm going to actually edit the title so that it does say the second session for. Oh my god. This is why you shouldn't open 20. Ah, here we go. How to build an OK Asim AI in JavaScript part 2. Okay, that's what we're going to look at today. So, what did we get to last week? So last week, so my goal overall for this thing is to build an OK Asim, just the same way as you might build an OK Google, all in JavaScript. And I'm using TensorFlow.js, which is a whenever you say OK Google, the phone. It's done it again. The phone starts. But I should put that to the side for now. But yeah, so we're going to build an OK Asim. So it's essentially the same as OK Google, a trigger word. I want to retrain or create my own trigger word called OK Asim. Have something in JavaScript that can listen for OK Asim, then we'll do something. Now to do that, I'm using TensorFlow.js. TensorFlow.js is a JavaScript version of TensorFlow, which is a machine learning library. It can do a bunch of different things. One of the things it can do is it can run pre-trained models. And there's a pre-trained model called a speech command recognizer, which has been trained to listen to over 20 items. Where were they? So start, I think it was. So it can understand like 8, 7, yes. So this is a pre-trained model, and what we did is we took it a step further and we tried to essentially train our own model, which we just went through the official TensorFlow tutorial to basically build this little nifty little thing. And what this does is you can then train it to just for your own left and right to move the slider left and right. So I'm going to try it again this time. It was quite fun last time. Let's do it. So I'm going to by pressing and holding the button on the left or the right, it will get some samples for each one. So for left, I'm going to try and do clicking the fingers actually, and for right, I don't know, something like that. How about that? Oh, okay. Uh-oh, that doesn't seem to be functioning as I wanted it to. Okay, so and then we need some background noise. I'm just going to let it listen to noise. And I'm going to train it. And what this is doing is taking all those examples and it's essentially creating its own neural net to essentially understand those. It ran through all of those, I think 500 things as a data set, ran it through the neural net 10 times, and each time it ran it, it got to increase the accuracy. And until we got to 99.2. And so now theoretically, if I start listening and clicking my fingers, it should move left and should move right. So let's give that a go. pretty cool. Actually, that's a hell of a lot better than what we ended up. I don't know what I was doing at the end of the last live stream I did. I didn't quite get something this good, but you can see it's kind of okay. Very good, actually, very good. But you can still see, even as I'm talking right now, it's still doing. You're still moving it left and right, so it's not amazing. It's not perfect. I'm sure sometimes it's going to think. Just by talking, it's going to think I'm doing it right. Whereas when we build something like OK Asim or OK Google or Hey Siri, you don't want it to ever accidentally think you said Hey OK Asim. You don't want that to ever accidentally happen. Whereas you can see here, accidentally, just by talking, it's thinking I'm sometimes saying left, I'm sometimes clicking, I'm sometimes going right. And that's because, we just did a very, very simple neural network here. This was not a complex thing that we built. In fact, looking at the source code, looking at index.js, you can see it's only like 170 lines of code. If you actually look at the model here, and this is the entirety of what we'd call the neural network model, is right here. Now, I made the mistake last live stream. I did make a mistake. I do apologize. I did say that I was building a transfer learning model. I wasn't going through the tutorial. I do blame myself. I do take on responsibility. But the tutorial title from the TensorFlow.js website did say transfer learning. However, it wasn't. The code itself wasn't transfer learning. And afterwards, after the live stream, I looked at it and I thought, you know what, that isn't transfer learning. Am I going mad? And it's not. This is basically just normal learning of a model. It's normal, absolutely bog standard machine learning model. It's not what we call transfer learning, which is what we really need to do in order to get a good model, a good solution for OK Asim. So what this means is it's just a raw model. When you create this model here, it's literally like a blank slate, like a little baby that's just been born, or just been conceived, nothing there in the slightest, no preconceived notions, completely blank. Then we take our data, our raw data, which is the left, the right, and the noise, and we're passing it through, and we're training it from scratch, but for like a human equivalent of like 10 days, right? And then we basically end up with like a 10-day-old baby model that's like this. And maybe it can understand. But then it's getting really confused because of all of the things. Because really it's just a baby model. What we have here, the data set here that's provided by TensorFlow, by the speech command model, this has been trained up. And I think it actually tells you how long it's been taken to train up from. Maybe it doesn't. I'm sure I saw that somewhere. But basically, I think it's taken like 50,000 iterations or 50,000 samples. There it goes. It came from 50,000 examples. So we did like 500 samples. It came from 50,000 examples. So the model here, the original one that I showed you that's coming, this is actually much, it's a brain that's been trained up a lot on a lot of data. So it's actually much better than what we built. What transfer learning is you take this brain that you taught just 20 words. I want to take this brain and I just want to teach it OK Asim. Because a brain that can understand 20 words is probably a brain that can understand OK Asim. And that's what transfer learning is. It's taking like a brain, like a machine learning model that already knows, was already trained on a lot of stuff and can kind of do this thing pretty well and going, okay, I just want to retrain it for my data, for my use case, to be very, very, very explicit. And typically also involves kind of like scraping away the last layer, which in terms of code, I mean, these are all layers. One layer, another layer, another layer, another layer. It'll just be stripping away the last layer, which the last layer is a thing that figures out if it's down, right, 7, 6, and we just want to add another layer for OK Asim, right? That's transfer learning. And that's why transfer learning is so exciting, I think, for JavaScript developers, because in JavaScript land, we really are not going to be number crunching this thing with 50k examples in JavaScript, even in Node. It's just not, JavaScript is not the language to do that numerical computation in. However, I do think in JavaScript there is the potential of it being powerful enough just to take an existing model, scraping away the last layer and just doing kind of just the last layer training with some examples. And typically you don't need 50,000 examples, you need much fewer examples to get some good use cases. That's the kind of stuff that I think we're going to be able to do in JavaScript. In fact, that's the kind of stuff I think we're going to be doing very commonly in JavaScript land over the next whatever years. So that's kind of what we want to do. Hopefully that's explained a fair amount of what my intention here is. And I'm just going to 2 seconds. 1 second. I've completely messed something up. 2 seconds. Let me just figure it out. Just a second. Close tabs to the right. YouTube. Let me just go YouTube. Start from YouTube again. Can't quite figure out where my live stream is. Okay, here we go. Awesome. If you've got any questions, fire away on the right hand side. And also, what I will do, I'm going to make a little plug for my book that I'm writing. So I am actually creating I'm writing a book, I should say, or I'm planning to write a book on create a video course on TensorFlow.js, and you can find it here. So if you search on Kickstarter for machine learning and JavaScript for absolute beginners, I'm about 60% of the way funded with 18 days to go. So I do need your help. I am asking for your help. I'm going to paste it in the comment window. So if you do like what I'm about to show you, or we're about to with this live stream, go away and please support my Kickstarter, because I have 18 days to get to the final number, and then I'll write for you a beautiful course and some books on TensorFlow.js and machine learning. All right, so let's get going. So the thing I'm going to do today is, if you actually look at the GitHub for the speechCommands model, further on down, it actually does have an example for transfer learning. Okay, so we're going to do this one. So previously what we did was not transfer learning, was just learning. What we're going to try now is transfer learnings, where you start off with this model here, and you lobotomize it, and we retrain it with some new commands. And to begin with, I'm just going to do it almost exactly as they say here. In fact, let me do old school. Here we go. This is how we used to do source code control back in the day. Well, no one did it this way, but I'll do part one. But maybe I did it. Maybe I used to code like that. Maybe. So let's have a look at this stuff here. So what we've got, and I haven't done this yet. So this is why this is really nerve-wracking for me whenever I do these things. Let me give it a go. And where am I? So what I want to do is I want to create a base recognizer, which is a speechCommands recognizer. Let's go up to the top for where, you know what? Let's just do it there. Okay, base recognizer, and in fact, I might as well get rid of the whole. Oh no, it was here. This is where I was, so let me stick it back here. Okay. And actually, I will make the variable const recognizer. I'll stick that at the top. I'm just doing that so that other functions will have access to the recognizer. This is doing what it's doing. It's basically loading the speechCommands, the pre-trained model that we mentioned before, and just making sure it's loaded, and then that's it. So hopefully that's all. And in fact, I'm just gonna console.log model loaded ... and then we know it'll be loaded. So if I now go into here, well, that should have automatically. Oh, sorry. So that's giving me an error already. What's the error? Assignment to yeah. You can't assign to a const. Nice one, Asim. And I've still got the UI here, so I'm just going to get rid of this. I'll leave that there for now, actually. I'll leave that there. Okay, so now the model's loaded. So now we know that's good. Okay. So each instance of speech command recognizer supports multiple transfer learning models, each of which can be trained for different new vocabulary. So in this case, what they're doing here is they're retraining it to recognize numbers. Yeah. They're retraining it to collect numbers, to get data sets for numbers. So what I'm going to do is, you have to create a transfer recognizer. So let's do that. Transfer recognizer. I'm going to do function, do transfer color recognizer. Recognizer. I'm going to mix between American and UK spelling. No, I'm not. Let's just stick to American. Come on then. So that creates, and then I'm going to call that from here. Okay. I'll call that from here. So that goes color recognizer, which then is going to create. Oh, that's the base recognizer. Okay, so it's going to be something like this. Yeah. You know what? Why am I being so fancy? Let's do this. Let's do this simple. Let's just do this as a really simple script like this. Nothing fancy, just a couple of lines of code. Here we go. And let's add some semicolons, because semicolons are fantastic. I love semicolons. Right, let's go. How do I make this go left? Okay, whatever. If I'll do that. Okay. Right. Going back. Now we're going to collect some examples. So we must want to collect some examples of me saying red, perhaps. Let me read through it first. Actually, let me just try it. I'm going to just try that. So here we go. Oh, is it a top level or wait? Interesting. So then, do you know what? Let's do it this way. Model loading, creating transfer. There we go. Model. So you're seeing one of the reasons I'm doing this is so you see the weird way, just how I code. I don't know. Do people find it interesting how I code? People claim to find it interesting, so that's what I will do. So I'm going to do creating transfer recognizer, right? And then collecting example. Examples. So let me see what actually happens if I was to run this. Ah, yeah, okay. So await is an asynchronous thing, and it can you run it from within an async function like that, async functione, and I'm going to call it app, and I'll stick all this in app, and I'll call app, and then that should be all we need to do. Await, you can only use await if it's inside a function with async. That's pretty much it. So collecting examples. How is it collecting examples? Is it collecting right now? Is it? So let me do. Right. So model load. Oh. Oh, it collected. It must have collected some red. Interesting. Anyway. So let me keep on going. Transfer learning model. So then it wants to collect background noise. And then why are we collecting green and blue again? Have they just messed up? I think they've literally just messed up. Ah, okay. Okay, so I think this code's a little bit rough. I need to know what this collect example does. So I'm just going to have a quick look, seeing if I can have a quick look at the source code. So where would it be? Let's go to index. Let's go to collect. Oh no, you can search. Why don't I just search? I want to search for, where's it gone? Collect example. Yes. Yeah, so this is the README. This is the type. Demo. Oh! Oh, there's a demo? There's a demo. Oh, there's a demo! Oh, I wasn't aware of this. There's a whole... Oh! Okay, I know what this is. Okay. There's a collect example. Duration seconds. I knew there was an option. Duration seconds. So I'm sure that's one of the... collect example, word, collect example options. Okay. So, I don't want that. I want the actual Goram code. So types. Will that tell me anything? There we go. Example, collection options. Here we go. Duration. One. This is the ratio between the duration of the to be collected example. One sounds good. Duration. Second. Optional constraints for the audio track. Snippet, duration in seconds. On snippet, include raw audio. Oh man, I should have got more sleep before this. Okay, duration seconds. So what we want, basically what I'm trying to do, I'm probably just not talking enough right now, am I? What I'm trying to do is I'm trying to figure out, I'll need to do something which collects, on a button click, collects me saying red. And I want to know how long it's actually waiting for. Oh, why don't I just look at the code? Create transfer. I want to open. Ah, it's not Node. Okay, so that's why I'm basically trying to figure that out. And in fact, what I'm going to do is I am going to change our UI again. So when we had left, right, and noise, I'm just going to collect red. I'm just going to collect red. What am I going to do? Let me think for a second. I'm not doing this very well. What do I want to do? What do I want to do? I want to what do I want to do? I want to basically execute this, and I'm going to run it a couple of times. Just going to click red. Okay. I don't know how long it's going to do it for, but I'm just going to keep on saying the word red, 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 red. Oh, I'll do this. I'll do say red. Say red. Yes. Say red. Say red. Say red. Say red. Say red. Say red. Right? And I'll say red. I'll correct a couple examples of red. I'll just do a couple. Then, what do I want to do? Oh, I've lost the actual. Oh, this is it. This is it. This is the actual code. Why doesn't it open up to exactly the page that I want? So let's look. Collect example. Oh, here we go. Ah! Name of the word must not overlap with any of the words in the base model example. Fine. The example collection options. Okay, let's have a look at what this is all about. Example collection options is duration second. Oh, let's have a look at it. Let's have a look at example collection options. Oh no, it's from somewhere else. It's from types. So this should be types. Here we go. Oh, I did see in types. Oh, I was already here. Oops. Okay. Duration seconds, if specified. Okay, so it doesn't have a default. So let's go back into here and see what the default is. So where was I? Yep, there. Okay. So duration multiply duration. If options duration is not equal to null, okay, fine. Okay, duration second. Right. What am I trying to figure out here? Snippet duration second. Snippet duration second. Snippet duration sec. If is not equal to null, then assert that the duration seconds is greater than 0. Frame duration second is equal to some FFTs decide divided by framework rate, and number frames per spectrogram. Oh man, this is complicated. But then if we've got duration second, why am I not seeing that? Why am I not seeing duration second anywhere on this page? Where is it? Where is it? Am I going to go nuts? How can it only... okay, so it's not... Could do with a little bit of docs here, people. A little bit of docs. Let's look at snippet duration second. CF, snippet duration second. Alright, I don't know. I'm just going to do it the hard way. I'm going to figure it out by looking at it. Alright. So let's just click those examples. Let's see if this works. So I'm going to do finished here. I'm going to do it the hard way and do it this way. Okay. So now I'm going to go back into here. Red. That could work actually. Now I've just wasted a lot of time. That actually is not too bad. I can live with that. I can live with that. Fine. I can live with that. Yes, I can definitely live with that. Okay, cool. So let me go back. Speech commands, go back to there. So that's how I'm collecting examples. And we also need to collect background noise. So let me do that as well. I'm going to do it here. In fact, what a shitty piece of code. My God, man. You are better than this. So record, collect sounds. I want to do this in a loop. Like, why would I do it not in a loop? Name. Recognizer. Recognizer name. Count. Right? So, we're going to collect 10 examples. Async function. So instead of doing say red, say red, say red, say red, say red, what I'm going to do is do something like this. And I'm going to do a loop. So I'm going to say for I is equal to 0. Let I is equal to 0. I is less than count. Count. I plus plus. Say, and it's going to be name. Say name, and I'm going to use to make it amazing. I'm going to use template strings. Boom, boom, boom. And then I'm just going to pass the name in there. I'm not going to use that. I'm going to use this. Okay. So then instead of here, I'm going to go collect sounds. I'm going to pass in the transfer recognizer. I'm going to collect red, and I want to collect 10 sounds. So let's give that a go. Okay. All right. Let me zoom in on there and B that out. Okay. Oops. Error. Okay. Oh! You forgot another wait. Because collect sounds is async, we want it to wait at 14 before it moves to later on. So what was happening there before? It was calling recognize a collect example and recognize a collect example. You can't do it two at the same time. So I have to do a wait. And what that happens is that at line 14, it waits for all of these to finish. Then it finishes and goes to line 15, then line 18. So that's what was going on there. So I'm now going to... Okay, so let me do it again. Red. What? How? Why did it say red 10 times? Oh my God. Look at that. Man. I hope you're as embarrassed as I am about my coding skills, because no, this is fine. This is absolutely fine. This is normal coding. This is what normal people do. I'll do it again. Red. 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 That's not bad. Who says you need user interfaces? You don't need GUIs. You can do everything the hardcore way. All right. Now we need to collect some background noise as well. So that's why I put it into a loop. So then I could just, as well as collecting red, I could then collect background noise. And I'm going to do exactly the same, but I'm not going to say anything. I'm just going to let the noise of the background, natural noise, like the fan and stuff, maybe my breathing. So I'm going to let that collect. Red, 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 red. There you go. So that's it. That's it. Basically, that's the core of it, I suppose. Where I've got some data at the very least now. Let me see if you've got any questions. Feel free to ask any questions if you have any questions. Right? Feel free to ask any questions. Oh, I have a question. Can I download it later? I don't think you can download from YouTube. Can you download from YouTube? I don't think so. I'm not sure. If you can download from YouTube, download from YouTube. You can watch it later for certain on YouTube. That's for certain. Next up. Let's go back to here. So now I have collected some examples, and then you can check the counts. Oh, I can just print some out. Then I'm not going to do that just yet. And then you can do the actual training. Yes. Cool. So just to make things easy, I'm going to I've got a couple more steps before I really put this thing out. You know, do it properly. So I'm just going to collect one example of each for now, and then at the end, do you know what I'll do? Here we go. Const examples. No. Yeah, examples. And I'm going to set it to 1 there. And then in the future, if I just want to change it, I've just got one place to change it. I'm not going to forget. And that one, I don't need to actually have that there anymore. So let me go back to, I want to actually see. Yes, so let's just count the examples as well, just to make sure that's working. Here. Excellent. So I am now going to go here and red. There you go. There's the examples. You know what I'm going to do is I'm just going to get this up and zoom it. So we're ignoring the UI for now. In fact, we can even then in that case just pop the whole thing out. I don't know if you know you could do this. You can pop the whole thing out and just have that. Okay, that's perfectly fine. All right, let's move on. So now this is the actual thing that's actually going to do the training, the number crunching. And we haven't actually gone into what the original model was doing, but basically it's you have to watch the first video to get like a very high level overview of what the machine learning models do. But what this is doing is it's basically going to take all of the examples that we've just given it, take the existing model, the existing brain, and kind of start retraining it just with those new examples. Epochs is, so if we collected 10 examples of red, epoch is going to be the number of times we take all of those examples and we train it through. Imagine the number of examples is a number of times, is a number of textbooks you've got to read for an exam. And epochs is a number of times you read all those textbooks. Right? That's one way to think about it. And so every time on an epoch end, every time you've gone through all the data set once, it's then going to call this function, and it's then going to print out the current epoch, 1, 2, 3, 4, 5, whatever. The loss function, which I'll explain in a second actually, and I think the accuracy, I'll explain both of these now actually. So what happens? What happens with machine learning? Okay, what's it all about? It's all about being able to represent problems as numbers. That's number one. Everything has to be represented as a number. Even these things that are strings or words or concepts, or is it a cat or a dog? It's just a number. And then what you do is you basically have to calculate something called a loss function. And what that is, that says, okay, given this this data that we've got, I want you to predict some things. So for now, we're going to give it some voices. We're going to say red, and we want it to predict that I mean red when I say red. So the data we're going to give it is actually raw audio data, and we want it to tell us red or noise. Okay. And as we train, what we do is we kind of we quiz it. Like that's not a bad analogy, is it? It's like you're reading textbooks, you're learning, then every now and again we quiz it. And what the quiz does is we say, well, given these things that we know, like we know this sound is red because Asim said the word red when we told him to say red. Given that, how you doing? How's your training going? Okay, you're year 5 into epochs. How's your training doing? And your loss is kind of like how many wrong answers you got, and your accuracy perhaps is how close you are at being a very, very accurate predictor of things. And they're not equal and opposite. There is a difference between the two. That's actually not a bad analogy. I'm going to reuse that one in the future. Putting yourself in pressure for analogies is good. Yeah, so basically your examples that you're collecting is like the textbooks you need to read. The epochs is the number of times you're going to read through all those textbooks to kind of learn stuff. And your loss, so every now and again, every epoch you do like an exam or a quiz with some of the data. So what you really do is this. You take, if you've got 10 examples, you really only read, if you've got 10 examples, 10 exam papers, 10 books, you only really train it on 8 books. You leave those 2 books to the side. And then what you do is you then quiz them off the 2 books that they've never read before, right? And so then you know that they're not just kind of like cheating by reading their book and kind of reading it out. So it's a nice way of kind of testing it. And so what we do is we test it on just the two books that has the rest. There's a couple of those examples, those reds, I'm going to say, it's not actually going to train it with them. It's going to keep them to the side to quiz the model with. And then that's how it figures out what the accuracy is, right? Because basically it will then just quiz you off the stuff you haven't seen before, and if you're doing a pretty good job, then your accuracy is pretty good, because that's data. Those are examples you've never seen before. So it's like a quiz, like an exam. It's like doing a past paper versus doing a new paper you've never read before, right? You can redo a past paper, but they're never going to give you a degree based off of redoing a past paper, because you probably just remembered it. And a machine learning model can actually just remember stuff and short circuit things. It's not cheating, it just does it. Whereas if you give it an exam it's never seen before and it does a good job of it, you know it's accurate, and that's what accuracy is. Man, that was a long explanation, but hopefully actually trust me, that's a very good explanation. I've given this explanation several times and I like this one that I've just given, so it's a good explanation. So that's what we're going to do. We're going to grab this code and we're going to paste that in here. Okay, and it's going to train. Now we've only got one example, so it's not going to do a good job, but let's just do it with one example. And we'll do it for 5 epochs. And then we'll just go that way. Let's give that a go. So remember, we've only got one example each. Hang on. Red. It's not done a bad job, has it? So here, epoch 1, the loss was a 0.5. So what a loss is, remember, a loss is kind of how wrong you were. It's not exactly, it's a bit more mathematical than that. But a lower loss number usually means it's better. And a lower loss number doesn't mean greater accuracy, right? A loss is a number of times you've gone through a past paper and how better you are at going through past papers. How better you are going through past papers isn't exactly the same as how much we predict you're going to be good in new papers. It's probably closely related, but it's not a given. Accuracy is how much we predict, because then we test you on a paper you've never seen before and data you've never seen before, and then it gets pretty good. Now our data set is really, really, really small, so it's not going to be good. But you can see the fundamentals of how it works here is a loss is getting less. Well, here it goes 0.5, 0.15, 0.35. So it went higher there, then it went lower, then it went a bit higher again. So it's kind of like going, loss is kind of going down like this. Accuracy, because we do not have many data sets, the accuracy is not going to be good, because we're not going to have any examples, really, are we? It's 0.5, then 1, then 1, then 1. 1 it would be top 100%. So now if we added in more examples, I'm imagining things will get a lot more interesting. So let's add 5 examples. Red, 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 red. Okay, still not. The accuracy isn't still working out so well. I think we still don't have enough examples, but you can see the loss is becoming a little bit more. No, it's still kind of the same. Okay, so now with 10, let's try with 10 examples for the hell of it. I think 5 isn't even that much as well. Red, 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 red. Oh, still no good. Okay. I'm not sure exactly how many data sets we need to get some good accuracy. Probably quite a lot of data sets, to be honest with you, if that's not working. Or maybe actually what we need is more examples of different colors. Let's throw in there green, red, green. Let's throw in there red and green. Maybe more examples. Oh, let's do it again. Red, 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 green, 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 green. Ah, yes, I mean, interesting, yay! So now you can see we're getting like no more with more examples. We're getting kind of more interesting use cases. And our accuracy started at 0.26%, then went to 0.83, then 0.96, 0.96, 0.99. So it got quite high quite quickly. That's pretty good. Okay. So that's quite a lot of data. I'm not going to go through that again and again and again and again and again. I'll probably drop down the number of examples quite a lot. And you can see probably it didn't even need to go through a lot of epochs, but I will whack it up to maybe 10. And the more data you have, the more epochs and the more time you need to kind of crunch those numbers typically. But 10, 10's all right. All right, so then that's that. Oh, now let's go to here. So then here's the good thing. Here is the listening. So now we want to listen for what's being said. Once we've trained it, listen, and it's going to tell us green or red or background noise. So let's copy and paste. Let me see what is it going to do. Transfer listen. I remember this code. Okay, then after 10 seconds, it's going to start listening. Then after 10 seconds, it's going to stop listening. Okay, fair enough. That sounds good to me. So I'm going to drop that in here. Save that. I'm probably going to drop a couple of breakpoints in as well. I'm not going to do it with a lot of good data to begin with, just to save time. And I'm going to just put some logs in there, starting training. Then I'm going to do here listening. Okay, listening. Okay. Do you know what? I'm going to do that I'm going to do 3 examples each for red and green, and then I'm just going to let it run and see what happens. Okay. No, not the right one. Red, 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 green, green, green. Red, 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 green, 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 Is it not actually printing anything out? Hang on. Why is it not? Maybe it's just not good enough. For let's stop a debugger. The problem with this is, because you have to retrain every single time, this is going to drive me nuts. I'm just going to, just to make sure we get to this piece of code, I'm going to just drop, I'll do one example each. And we'll give that a go. Alright. Red. Red. 1, 2, 3. Okay, now we've got some results. So it's given a scores 1, 2, 3. So I think, I think it only calls once after 10 seconds. Is that right? Hang on. That was interesting. Why didn't it print anything out? Why didn't it print anything out? That was weird. Console.log scores for the word. That should have printed something out. All right, let's give this a go again. I think it's because of probability threshold. So it's only going to give me a callback if it's pretty certain. So let's drop that certainty down. Oh, this isn't the code. Let's drop that certainty down so that it will call me back in more favorable segments. One second. Red, green, red. Yeah, I can't remember what number 2 is, but yeah, so it's pretty certain about something. The words, 2 is red, excellent, so it knew I said red. And why is it not printing it out? That's so stupid. Hang on. It's just not getting to 38. So there's some stupid code happening here. Let's have a look at this. Okay, something is not working. Words is not. Man, I need to help these people out with their code. I'm going to make some notes of this. I'm going to put the notes. So things that are wrong to fix in code. So this isn't words. So words isn't a number. This should be words.length, I think. Oops. So if I go over here, so words is an array. So they've gone. If you look, it's an I is less than words. Words is an array. So you need to do words.length. So here you go. Even code is even code in kind of big repos is broken, and you can fix it. Do you know what we'll do? We'll actually fix this. Here as well, just to help them out. So we go words.length. So now if I refresh this, red, green, red, dump over, words, and it should go over in there. Why are you not? Yes, finally. So hopefully that should then print everything out in the console. Yeah. Alright, so then let me send this. So it wasn't this, I don't think. So I'm going to set that back to there. I'm going to get rid of the debugger. Alright. And let's print out heard. And then after it's done, I'll just print a lot of dots or this. I'll put that at the top as well. In fact, I'll just do it that way. Okay, right, let's give this a go. Red, green, red, red, green, green, red, red. You can see it's red is like it's 99. Green. Oh, it stopped listening. That was actually working pretty good. That was working pretty good. Right? Pretty good. There was one moment I think it thought I said green. It was actually background noise. But let's give that another go. Okay. In fact, what do you want to do? We want to... There was some code for this where it'll just print out from the old world. Here it was. This is the old code. This was it. I remember this. Don't worry, I will show this in a second. That's from the previous code. So a better way. What we really want is we want the actual thing. We want the word that it thinks it is. So this is from the previous weeks. So there was result there. Scores. Words I. Yes, I remember this code. And then what you did is you sorted all the scores. Yes. And then you took... What did you take? You took scores. Score 0 word is what gets printed out. Okay, fantastic. It's fantastic. Okay, let me close that. And so instead of this, let's just print out. In fact, let's print out. Let me get rid of that. That. Score for word. Scores. We want the first one on the list. So the first, that means it's the highest score, and it's going to be the word. Word. And then it's going to be. Oh, I missed one out there. Then it's going to be. The next one is going to be. And then I stored the score in score, and I'll drop a debug in this to make sure you all understand what's going on. And let's have some fun. No, 10 seconds fine. And let's do this. Red, green, red. Oh! Cannot read property word of undefined. Cannot read property word of undefined. It's property word of undefined. Oh, that's interesting. Do you know what I have to do? I have to just really quickly look at the previous week's code, because recognize a list and scores. Scores is equal to array from scores. Scores is equal to array from result. That looks good. I'm going to drop a debugger in there. Okay. You got to learn how to debug, people. If you want to get good at coding, you have red, green, red. Okay, so result. Result dot scores. That's what I want. You see, I was thinking I want the array of scores, which is the inside result as dot scores, and that's what I want to pass into here. So let's now. So result dot scores. As I said, have to get good at debugging. In fact, I want to get rid of the debugger. I'm feeling lucky. Red, green, red, red, green, green, red, red, red. Oh, stopped. So you see, sometimes it was giving me 2. I think it's because it's sampling. It's sampling It's doing it. It's not listening for red. So I don't know exactly how to do that yet, but I think that's what it's doing. So let's have some more fun. Let's do it for 20 seconds listening, and let's collect 10 examples each. Let's go for that. Red, 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 green, 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 green. Accuracy is pretty good. Red, 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 green, 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 red, 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 green, green, green. Oh, stop listening. All right. The sharp eyes of some of you there might recognize we're pretty close then, aren't we? We're pretty close to getting to okay, Asim. I mean, I think all I really need to do at this point is let's forget about red and green. Hate red and green. They're the worst. I'm gonna say okay, Asim. Or maybe just Asim. 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 And do you know what? I'm also going to collect examples of the other ones for the hell of it. Hey Siri, okay Google. Do you know what? I'll do okay Google and okay Asim, because I do not want those two to get confused. So I suppose that would be the big one. And I do want background noise as well. Okay. All right. Let's do it, people. I think we're ready. No, I don't want 10 examples. Let's start off with one, actually, because we didn't get too bad results with one. Okay, Asim. Okay, Google. No, that wasn't good. Let's do that again. No, do that again. Okay, Asim. Okay, Google. Okay, Asim. Okay, Asim. Okay, Asim. Okay, Asim. Okay, Google. Okay, Asim. Okay, not the best, but we only collected one example. Let's now collect a whole bunch of examples and give that a go. Okay, Asim. 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 Okay, Google. 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 Okay, Asim. Okay, Asim. Okay, Asim. Okay, Google. Okay, Google. Okay, Google. Okay, Google. Okay, Asim. Okay, Asim. Okay, Asim. Okay, Asim. Okay, Google. Okay, Google. Not bad, you know, and you can see, I don't know if you saw that, that's actually getting a lot better. Just having a whole other bunch of examples made it get a lot better at recognizing. So I'm going to do, should do 20. I'm going to do 20, and do you know what? I'm going to do 20, and we're going to do 25 epoch training. We're really going to go for it right now. I'm going to let it run for like 60 seconds so I can have some fun with it at the end. All right, people, here we go. Okay, Asim. 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 Okay, Google. 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 Here we go. Ooh, is that accuracy get? Oh, it's pretty far. Okay, Asim. Okay, Asim. Okay, Asim. Okay, Google. Okay, Google. Okay, Google. Okay, Asim. Okay, Asim. Okay, Asim. Okay, Asim. Okay, Google. Okay, Google. Okay, Google. Okay, Asim. Okay, Asim. Noise isn't making a difference. And I'm just standing randomly talking. I give it okay, Google. Randomly talking doesn't seem to. Well, it does create some issues right now. I'm sure with a lot more data it will be even better. Let's do okay. Okay, Asim. Okay, Asim. Okay, Asim. Okay, Asim. Okay, Asim. Okay, Google. Okay, Google. Okay, Google. Okay, Google. So again, the more data you give it, if it's really much more of a data problem, the better it can get. But I think compared to kind of what we had last time, which is the clicking, the left and the right, the most important thing is with background noise right now, it's not really messing up, right? It is actually doing a good job, and that's because we use transfer learning, which kind of took an existing model that was already pretty good, pretty good at recognizing certain sounds. We then lobotomized it and we said, you know what, forget about the stuff that you know, and we kept its kind of like raw fundamental understanding of the processing of sound, and we stripped away its understanding of what sound, what words those sounds mean. We kind of kept the base, auditory stuff, and then we kind of trained on a new thing on the side that all it knows is okay Asim and okay Google as well, I suppose. That's it. That's it. I think for next time, we're probably going to start looking at. There's a whole lot of. We just basically ran this inside the console. What I'd like to do next time is really trying to figure out how to, perhaps not say okay, Asim, okay, Asim, okay, Asim, okay, Asim, okay, Asim 1,000 times. How can we actually load up me having said that in a data set somewhere? So so we don't have to do that. And at the same time, how do we then export this model? Like, I've trained it. I need to, if I want to put this on a website somewhere, I'll need to actually export that model in some sort of JSON or something, and then which I can load up somewhere else. So pretty exciting stuff. I said I was going to make an OK Asim. I made an OK Asim. Yes. All right, people. See you all next time. Oh, quick reminder. Again, one more time. You can have a look at the link in the description, and you'll find my Kickstarter I'm currently working on. If the Kickstarter is actually finished by the time this feed is by the time you get to this YouTube, the link will be changed to the actual book. But I am looking for some support and help. I am trying to write a book and create a course on TensorFlow.js. It's on Kickstarter. I'm about 60% funded. I need another 40% of the funding. I've got 18 days to go. If you are getting this in the next 18 days, please come support me and let me know. And I'd really appreciate it. All right, cheers, bye.